All right, good afternoon or good morning whenever you're watching this. This is just a quick little intro on the properties of equality. So we're not going to spend a whole lot of time, but this is something that is going to be super helpful to you when you move on to geometry. And this kind of explains why we do what we do in algebra. Okay, so if you look, you have a list of some properties of equality. And basically, this is a way of saying what we do to one side of an equation, we do to the other. That's what keeps it equal. So think about it. If you have a perfectly balanced scale, okay? So I can't draw, but let's say you have a perfectly balanced scale. If I add something to this side, what's going to happen to the other side? Well, this side would come down and this side would fling up. So if I add something to the right side, I have to add it to the, or if I add something to the left, I have to add it to the right. So it goes both ways. You have to keep things balanced. And so these properties of equality are a way of keeping both sides equal and for keeping everything balanced. So, clear everything. And let's go ahead and get started. So, our first, so these are just some ways of using properties of equality. If you look in your Springboard text, you should have a, if you look at page 16, you should have a list of these properties and what they mean. Okay, so let's start. So the first thing we have is we have an M plus N plus P. My second line is M plus N plus P. The only thing that's different is the parentheses changed. What this tells me is that I can add M and N first and then add P, or I can add M and P first and then add M, and they should be equal. This property is called the associative property of equality. And I'm going to abbreviate with POE. So POE, oh, this is property of addition, not equality. Property of addition. So that was the associative property of addition. And what associative means is I can put my parentheses, let's use numbers. If I can do 1 plus 2 and then add 3. That would be 3 plus 3 is 6. Or I can do 1 plus 2 plus 3. Well, 2 plus 3 is 5, plus 1 is still 6. You get the same thing either way. So let's clean this up. Oh, I thought it was, okay. Thought we'd take it out a little more than that. Okay. Next thing we have M equals 2 and P equals 5. That's given to us. So if you notice, everything starts with given. Given just means that we already know this. We don't have to use any kind of math to get this. It was given to us. So we have that M equals 2 and P equals 5, and then we're given this expression. And then it asks us to use substitution. So we have this right up here, the substitution property of equality. Now, if you think about the term substitution, like if I have a substitute in class, that means that she is taking the place of me. So we're going to have these numbers take the place of our variables. So we have a 2 plus 5x. I substituted 2 for M and 5 for P. So that's the substitution property of equality. Okay, so let's look at our next example. We have M equals P and Mn equals Pn. So if you look, I now have an N on either side. Well, how did that N get there? So if I have two letters side by side, that means I've multiplied. So I multiplied each side by N. That's the multiplication. I cannot spell, this is why I teach math. Multiplication, property of equality. That would be right here. And basically what that tells me is if I have two things that are equal, like I do right here, and I multiply both of them by the same thing, they're still equal. It's all about that scale. If I multiply the left side by something and I multiply the right side by something, so if I multiply both sides by n, they should still be equal. Okay. I want to clear all. Okay. So if you need to, I'm going to clear this because I'm running out of room and it's getting messy. So pause the video if you need to and jot whatever notes down you need to. Scroll this. Okay. All right. Okay, so we've done this one, this one. We've done multiplication property, associative, and substitution. We'll cross those out. Okay. All right, next set. We have m equals n, so m and n are equal. We have m plus p is equal to n plus p. So what I did was I took the same thing and added it to each side. So because I added the same thing to two things that are already equal, my equation remains true. The equation's still equal. So I added to both sides. That's going to be the addition property of equality. All right. So next one, this time they gave us the property and asked us to fill in. So we have n is equal to p, and then asks us to use the symmetric property. So if you're not sure what symmetric means, that means symmetric usually means if you have a shape, you can cut a line through it, and this side is the same as this side. So the two sides are the same. I can flip this. If I were to flip this or rotate it around this line, it should look the same. So we're going to take that logic and apply it here. If I were to flip these, they should still be equal. If n equals p, p should equal n. They should be equivalent either way. All right. Next one, m is equal to r, and then I have m over p is equal to r over p. So now it just looks like we threw fractions in. But if you remember what a fraction is, so like the number 3/4 actually means 3 divided by 4. And if you think about it, your fraction kind of looks like a division symbol. So you have a number on top of a number, which is kind of like a division symbol. So basically we're taking the top number, dividing it by the bottom number. So it's not just that I put them over the same fraction, I've actually divided both of these by p. So knowing that, you should know that this should be the division property of equality. All right. Next one, we have p is equal to r. P minus n is equal to r minus n. Again, we're doing the same operation to both sides. We're taking we're subtracting for both sides. Shouldn't have to tell you, I think you know. That should be the subtraction property of equality. Okay. Yep, that's why. Okay. All right, so take a minute. I'm going to have to erase so that we can go on to the next slide, or next half of the worksheet. Go ahead, pause the video, take notes if you need to. Okay. All right. Okay, so we are here. No, we just did this one. Boom, 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 boom. All right. So we have n times p minus r, and it asks us to use the distributive property of subtraction. So I don't know if you know what distribute means. You should. You should have done distributive property in 8th grade, but think of it as when your teacher is handing out papers. She doesn't hand out your papers to just 2 students in the class. She gives papers to every student. So whatever's on the outside of parentheses, I am just using symbols at this point. We're going to take that and multiply it or distribute it to everything on the inside. So it works if this is a plus sign or a minus sign. Let's do it with numbers. Like if I had 2 times 4 minus 3. I can distribute that 2 and multiply it, and this becomes 8 minus 6. So think about it. You could have done 4 minus 3. That would have given you 1, and 1 times 2 is 2. Or you could multiply, distribute. You get 8 minus 6, which is also 2. So that's why we're allowed to do this when we have variables, because it works out to be the same thing. It works out to be true every single time. So if I distribute my n, I have n times p minus n times r. And I apologize, you're going to see this a lot. My r's and b's look alike. So that is still an r, it's going to look the same. All right, next we have associative property of multiplication. So remember when we did associative property of addition, we had 1 plus 2 plus 3, and it didn't matter which ones I put my parentheses around, it gave us the same thing. So it's the same concept except with multiplication. So instead of having n and p in parentheses, should have n outside and pr in parentheses. Thought I could just like clear. There's a button I'm not pushing, but that's okay. Okay, last one. I think, yes, this should be the last one. Okay, so we have p times m plus n, and then we're given, after that, we have pm plus pn. So what did I do to get from step 1 to step 2? Well, just like in this one, I distributed. So this becomes pm times pn. This is the distributive property. But instead of the distributive property of subtraction, what we did here, this is distributive property of addition. I'm so sorry for how messy that is. All right. Okay, so go ahead, jot that down. You can pause the video if you need to. Let me clear this. And then, yep, that should be it. If you have any other questions on properties of equality, I will link another video on Google Classroom, or however we're linking videos this year. I'm making this video prior to how we've set everything up. So here's a video on properties of equality, and if you need another one, let us know. Thank you so much for your attention, and I hope you guys have a good day. See y'all soon.